Hello everyone, my name is Siyang Mao, and I'm an offshore student from China. In our project, I mainly involved coding works of login page, sign-up page, class dashboard, and assignment dashboard. I'm sorry that I couldn't be with you in person in University of Auckland, but right now I'm joining this presentation via Zoom. Here is my name and student ID. I'm pleased to have the opportunity to present our project's motivation and introduction to you today. So the first part is the motivation. In our university, the marking system is a critical component of the academic experience, providing feedback and assessing students' understanding. However, the current system of manual grading involves a complex set of procedures and is both time-consuming and error-prone. This can lead to frustration for markers and the lecturers, as well as creating potential inaccuracies that may affect students' performance evaluations. Therefore, it is essential to develop an automated grading system that can accurately and efficiently grade systems assignments, saving time, reducing errors, and improving overall academic experience for both markers and students. And here's the introduction of our project. The RubrixMarker Pro is a system that we developed to facilitate grading and providing feedback on student assignments through a user-friendly grading website. It allows markers to log in and efficiently grade each assignment. With the RubrixMarker Pro system, changes in the grades will be automatically adjusted, thus reducing the need for markers to perform manual calculations. The system consists of two parts, the front end and the back end. The front end comprises web pages that allow users to interact with the system, while the back end holds an object-oriented database that stores information about assignments, rubric components, and students. The front-end web pages are designed to be intuitive and easy to navigate, which ensures quick and efficient grading. On the other hand, the back-end components of our system needs to be well organized and easily accessible. With the RubrixMarker Pro system, markers can seamlessly move from one student's assignment to the next, thereby reducing the chances of errors in grading or feedback. Finally, I would like to present our team's work division. To undertake this project, we divided ourselves into two groups. One focused on building the front end, and the other focused on the back end. The front end group consists of Minko Minkov, who is also our team leader, and followed by me, Siyang Mao, and Kevin Song. The back-end group comprises Solomon Park, Yucheng Liu, and Michael Low. My teammates are incredibly supportive. Whenever someone faces a challenge, the rest of the team is always there to help and offer their support. So this is my part of the presentation, and thank you for listening.
The front end is made using HTML, CSS, and Bootstrap for a simplistic and clean view. GitHub Pages hosts the front end as it makes it very easy to separate the servers and work on them separately. It also comes with Jekyll, a static site generator, which pre-optimizes the static files you've written for hosting. This makes it easy for GitHub Pages to host these files on their worldwide servers, which leads to lower ping times and faster site loading, since you can download the desired HTML files from a server closer to where you live due to how worldwide GitHub is. When needed, the front end makes calls to the backend to retrieve data. The backend handles tasks such as data storage, authentication, and serving responses to the requests from the front end. In this case, the backend is built using Node.js and Express.js in a monolithic server setup. A monolithic server setup is easy to understand and develop because the entire application is contained within a single application or server instance. This can help reduce the complexity of the application and make it easier to maintain and update. It also allows for vertical scalability. This means that you can increase the server's power and performance by adding more resources to the server. Ease of development, reduced latency, and lower costs are also benefits of a monolithic server setup, as all the components are in one unit. Since JavaScript is used for both front-end and back-end development, it enables a consistent language across the application stack. Express.js is leveraged to build RESTful APIs for seamless communication between the front-end and back-end. Adherence to REST principles is maintained for a standardized and scalable API architecture. As for hosting for the backend, AWS EC2 is used. It provides virtual servers in the cloud, allowing for scalable and flexible server resources. By hosting the backend on an EC2 instance, it can be accessible from anywhere with an internet connection, making it easy to serve requests from the front end.
Hi guys, my name is Yuchen, and I will explain the implementation of our database and the demo for generate report function. We all know database design plays a crucial role in the overall success of a project. It ensures efficient storage and retrieval of data, data integrity, and scalability. Proper database design helps in organizing and structuring data in the logical manner, make it easier to work with. We choose MongoDB as the database solution for its flexibility and scalability. MongoDB Atlas simplifies our database management by providing a cloud-based solution. It offers scalability, meaning we can easily adjust resources as our needs grow. For security, we can also configure IP whitelisting to allow only specific IP addresses. And we can easily create project and add the team members into the project and assign different roles like admin, reader, or editor. So the whole team can easily access the database and share same view. It's a NoSQL document database that offers high performance and easy horizontal scaling. For example, when I open our database from the website, we can easily add any collection from the list right here or add any attributes for any specific students. The MongoDB document-oriented nature also allows for storing complex data structure. For example, students' assignment could have PDF, Word, or scripts. It all can be saved in the MongoDB Atlas. I would also like to show you the demo of the generate report function. From the website right here, I have my navigation bar at the top. It allows user to going back to any other function or page whenever they want. It enhances our user experience. From the drop-down list, you can choose any courses for this semester. And you can also choose, for example, homework 1 for mathematics 2023. Then you generate a report. You can see all the information like class, year, score, student UPI. And for the statistic chart, you can also see there's 50% students getting 60 to 70 score and another 50% getting 90 to 100. For future improvement, I'd like to add an assignment component score so I can see the different component score for each assignment or for one course and get the statistic information to compare students' score in this review page. In the end, you can also download the file right here. So you can edit and check the report at your local computer or bring it anywhere with your memory. That's all my presentation, and thank you for listening.
Hi there, my name is Minka. Welcome to the RubrixMarker Pro system. I can begin by logging in. We can see that it's hosted on our GitHub pages. I'll log into my teacher account. Just admin as the username. When I log in as the lecturer, I can see my list of classes that I have been assigned. So for example, I can see comp sci 335. When I click on it, I can see the list of assignments. I can also see the generate report area that was shown earlier. I can go and click on the view of the assignment, and then I can see a list of students and the files they've submitted. And I can go into the option to start editing a rubric or marking a student. For now, I'll click on edit rubric just so I can show the rubric editor system. Here we have what we call a what you see is what you get editor. And so all that really just means that any change you make, if you want to like bold text or highlight something, you can see it immediately, and this will be exactly what the output looks like too. So when you go to mark students, you'll see all this stuff. We do it by, so if I actually change the fonts as well, or highlights anything, or add bullet points maybe, I've already written some stuff here, or like, a little numbered list there as well. I've already pre-filled a bit here. You can also add in images. The way all this works is through the through an HTML output, and so it just stays super consistent across all our web pages, just because it's purely in HTML here. So I can also add in images, just to show that real quick. I've got an image here prepared for that. I can just drag it in like that. And there we go, boom. I've got an image there now. And I could do the same thing with these ones here. This is the marking table. You say how much each row is worth, and item is basically the description for how they could get those marks or obtain them. You can add an extra row here. So maybe this row could be worth 6 marks in total. And maybe they get everything just perfect. And why not? Let's add the tick in again, just to show how that works again. Well, it's quite a big tick. We can just we can reduce the size there. Put on a new line as well. It's got quite a few extra features here, but we won't really use most of them. But you can write code blocks as well, or you just have a variety of choice. We can change the maximum marks. Let's change it to 6 here. Each rubric is made out of multiple components. So let's go to the next component for now and save this one. And we can see some other stuff I've written. I can change its size to adjust it for how large I need it to be. I've got some stuff pre-filled here. I think I'll just leave it as it is. Save an extra rubric creator. Now when I go back to that assignment, I can see the amount of marks it's worth has been updated. I can also download a compiled version of the rubric, which is all the stuff I added in and saved. It's got both of the components compiled together, and it shows how much each component is worth and what someone would have to do to get the marks from each component as well. And it comes with the title and description, and just generally the small stuff I added in, like the tick and stuff. Anyway, I can also begin marking students, and it should appear on there as well. So here we can see the tick again, tick here as well. Let's say they get 6 marks for this one. The student got 6 marks. Overall, we're going to add, let's take away 1 mark. Maybe they did something small that was wrong. We can also download the file that the student submitted, so we can have the marking scheme up in front of us while we're marking them. You can click OK here. I'll go back there, and here we can see they got 5 out of 7. That's because they got 6 in the first part and then -1 on the second part. So altogether 5 out of 7 for them.
In the evaluation of this project, a thorough analysis has been clearly conducted, which allowed us as a team to determine which goals were successfully achieved and which goals remain unfulfilled. Among the goal objectives, one significant accomplishment was the development of the rubric creator and editor. This allowed for a much more efficient assignment management. Additionally, progress was being made in the implementation of a marking system for students, enabling initial assessments. A valuable feature was also incorporated. This was the feature to enable the marker to download an Excel file containing the student's results, enhancing data accessibility. However, along the way of goals being successfully achieved, it is important to note that the goal of adding in additional markers was not accomplished as intended. Throughout the project, our team has encountered a range of both technical and non-technical challenges, from which valuable lessons were learned. On the technical side, one notable difficulty arose in the initial attempt to utilize vanilla JavaScript for the front end without having to leverage on essential tools such as npm and Node.js. This attempt proved to be limiting and hindered our development efficiency. Subsequently, an alternative approach was adopted, which was to revert back to vanilla JavaScript, but this time integrating npm. This allowed us to facilitate the use of libraries and streamline the coding process. Another technical challenge was encountered in the front-end development was getting involved in the use of modern tools, such as Vue.js, which lacked sufficient online and community support. This limited availability of resources, which made troubleshooting and problem-solving difficult. Consequently, the decision was made that we pivot away from these tools and focus more on utilizing more widely supported technologies, which was reverting back to vanilla JavaScript, but with npm allowing us to easily use resources and be able to write vanilla HTML and CS code. Additionally, the implementation of a what you see is what you get editor posed a significant technical obstacle. A what you see, what you get editor required multiple attempts to achieve the desired functionality, as the availability of reliable libraries proved problematic. This was due to the fact that some were very buggy, otherwise came at a cost. Whereas the project was aimed to incorporate a free basic version with features like bolding and highlighting, this challenge necessitated through exploration and careful selections of appropriate resources. On the back end, however, adjusting to the peculiar structure of MongoDB and working with custom objects presented a learning curve. This complexity was further compounded by the involvement of multiple individuals working on different components of the back end. To overcome this challenge, it required effective communication and coordination among each of the team members. The project confronted technical challenges related to the front end, such as the choice of tools and the implementation of a what you see is what you get editor. While the back end presented difficulties with MongoDB structure and collaborative development, these obstacles proved valuable insights highlighting the importance of selecting well-supported technologies and fostering effective teamwork and coordination when handling with complex systems. In considering future directions and insights for problem at hand, several noteworthy possibilities emerged. An important avenue to explore next time will be the incorporation of additional markers, which was a goal that remained unfulfilled in the current project. By implementing this feature, the system will be more enhanced with the ability to involve multiple markers in the evaluation process, thereby providing a more comprehensive assessment. Furthermore, a promising direction to consider in transitioning to a modern front-end framework such as Vue.js, while the project initially faced challenges in areas due to limited online community support. It is worth exploring again with a focus on its potential benefits, particularly in terms of maintainability. By leveraging a well-supported framework, the project can take advantages of its robust ecosystem, ease of development, and enhanced scalability. Additionally, embracing a serverless architecture could prove advantageous for the system's future development. By adopting a serverless approach, the project would benefit from improved scalability and simplified implementation of scaling processes. This architecture would allow for seamless handling of increased workload and user demand, ensuring the system can efficiently handle growth and maintain optimal performance.
So now I'll talk about the conclusion for the backend. Starting off with backend goals met. I've listed here the functionalities that we've implemented. First being upload files. So when you go to submit an assignment, you upload your file. Every time a file is uploaded, it's stored into our file system and saved with a unique name based on date, time, and name of the file. You can then also download those uploaded files. And then a separate functionality is the ability to create an Excel spreadsheet report, as Eugene showed before. You can also create objects, and those objects being assignment, student, class, or marker. I've noted here that each assignment includes rubric details, and then that rubric field will have a component or components in it. And say you have a rubric with 10 rows, one of those rows will be a component, and each component is composed of the details of that row and also the maximum mark for that row. I've also noted that each student has their assignments and their assigned marks for that assignment. Obviously, if the assignment isn't marked yet, there'll be a boolean saying not marked, and then assigned score will be 0. But then if you look at the bottom here, you have the ability to update info, and so you can assign the mark then, or say assign marker, assign score, etc. You can also get all relevant info. So say you want to get all student marks for a specific class, you can do that, or get a particular assignment rubric. For the challenges, the main challenge that we encountered was just getting familiar with the technologies that we used. So we used JavaScript with Node.js and Express. We didn't learn these during university, but we wanted to challenge ourselves and learn something new. So for the database, we also used Mongoose from MongoDB. And so the entire process was also a learning process. I've also noted that Mongoose that we used, it's an object-oriented database. We predominantly use relational databases such as SQLite during university, and so that was a bit of a change in terms of how we effectively create, read, and update info from the database. But at the end of the day, I think I preferred this much better because there's a lot less setup compared to a relational database. For future insights, so currently our files are being uploaded and stored into a local file system. This is a clear scalability issue, so for future we will take advantage of cloud-based solutions by storing files into the cloud. Also, we don't have any security into our back end. Obviously this is important because assignment marks and student information is sensitive information. And so we would need to include robust security measures as well as encrypting sensitive information. Also, this is mainly for the lecturer's use. We would be able to generate different graphs for different demographics for a specific assignment. And so using this information, lecturers can effectively make decisions such as scaling or identifying if students are struggling on a specific topic. And then at the bottom of our priority list for future, possibly using a serverless architecture, and so this will automatically handle all scalability issues. And that's it from me. Thank you.